So I'm going to demonstrate problem 3. This is really similar to the problem that you have in your problem 3 in your applications. A professor wanted to know whether students who learned about growth mindset had better statistics scores than students in general. She knew that students in general receive statistics scores of 75 with a standard deviation of 7 points. She tested this hypothesis by teaching one student about growth mindset, and that student had a statistics score of 89. Using the 0.05 significance level, test this hypothesis. Assume the distribution is normal. So let's go ahead and parse the problem. Population 1, I can see, is students who learned about growth mindset. Population 2 is students in general. If you ever have this problem, you want to have this all show up so you can know what you're doing, go right up here to the formula bar and you'll see this arrow appear and you can just drag that over and get yourself a little more space. The dependent variable, what we're measuring, is the statistics score. And the tail of the distribution, I can see from this word had better. This suggests that we're looking at a one-tailed high. And the research hypothesis is that population 1 will have better statistics scores than population 2. I'm just going to write POP2. And the null hypothesis is exactly the same. So I'm going to copy it and paste it and just add the word not. Next, we look for the information about the comparison distribution. Remember, the comparison distribution is just that distribution that refers to population 2. So this is about population 2. And we can see in the problem that students in general, that's population 2, here, students in general receive statistics scores of 75. So that's the center, the average, 75. And I'll maybe make the mu here. The spread is listed as standard deviation 7. And the shape is normal. I'm going to write these up here now because it will make my calculation easier. I'll do the calculation both in Excel and by hand. So the number in the sample, I always want to put this here. This N refers to number, and it's usually pretty important. And we just have one person here, right? She only tested this on one of her students. So let's go ahead and just write 1 here. And let's go ahead and put this mu in here that we got, which was 75, and sigma, standard deviation, which was 7. And that little m there shouldn't be there because we're not in that chapter yet. There we go. It's just mu, just sigma. Next, we determine the cutoff point, and really we don't determine it. The researcher determines it. So let's just say, look up the cutoff point. So what that means is cutoff point is the z-score that's linked to alpha. And so alpha in this case is always going to be written in the problem, and it's this significance level. And sometimes it might be written as alpha, sometimes significance level. And it's 0.05. It's either going to be 0.05 or 0.01 in our studies. So alpha is significance level. And then the cutoff point we refer to as Z for alpha. So the Z-score for alpha, in this case, we need to use our cutoff point calculator tool, which I recommend you bookmark. Let me see where I put mine here. I bookmarked it and then I buried it under another. Here we go. So this is the z-value calculator, and all you need to know in these studies is alpha. So we just, and the tails. So we just determined that it's alpha 0.05 in a one-tailed high. So let's go ahead and calculate. There's that 0.05. Let's calculate. And we see that for a one-tailed high test or a right-trailed high, the critical value or the cutoff point is 1.65. So let's write that here and let's plot it on our chart too. Z alpha equals 1.65. And let's plot it on our chart. 1.65 is going to be in the upper tail, about 2/3 of the way between the 1 and the 2. Z alpha equals 1.65. And let's do some coloring here. We know that the shaded region is always going to be more extreme, or the reject region, we should say. And let's mark that any score that falls in the center here, we're going to fail to reject HO. And so that's what we have. That's our looking up the cutoff point. And now we find the sample z-score. And you can do this either by hand or in Excel. I recommend you get comfortable starting with Excel. So I'm going to actually start there. So first off, we have to look up X, which is our sample score. It kind of bugs me when these numbers are way off on the, on the left like that. And I'm going to actually change, I'm not going to change it there. I'm going to just change that so that it is all on the right. And I'm going to go home and just click this. And now everything will appear on the left. There we go. Now we can enter our sample score, which is, let's see here. It says she taught one student about growth mindset who had and got a score of 89. So is this score significantly different than what we might expect by chance? Well, let's figure out our z-score. So to do it in Excel, I always start with my equal sign. And I know the formula already. I'll write it here because we're going to do it with pen and paper after this. Z equals the score minus the mean. But in this case, we don't write mean anymore. We write mu. So let's erase the mean. And the only difference between mean and mu is that mean refers to the, whoops, I seem to have lost my draw menu for a moment. Oh, it's the reason I lost my draw menu is because I have that in the middle of a formula. So let's now get the draw menu back, get rid of the M. There we go. Can you tell I'm doing this kind of late at night? Okay, X minus mu divided by sigma means the same thing as X minus M divided by standard deviation. That's our formula. So now let's type it here. Equals, now I just put my cursor where put the parenthesis and then put the cursor where the X is. If you forget your parenthesis, you will get the wrong answer. Add the minus sign. I know I have to look for mu, so here's mu. Now I need to add a closing parenthesis. I'm just copying the formula and divide by standard deviation. And I come up with a z-score of 2. You could also do it by hand by going equals 89 minus 75 divided by 7. And you could get your calculator out and go 14 divided by 7. And you don't need your calculator because it's easy math, but usually you will. So our z-score is equal to 2. We can write that in here. Our sample z-score, our one person had a z-score of 2. Now we have to make a decision. We can do that by plotting our sample z-score. So let's go ahead and get that red pen out. Let's plot our sample z-score. Here's the 2. Z equals 2. And I can see that it falls in the reject region. Researcher is happy. We have a significant test. So we make the decision to reject the null hypothesis. And we conclude that, I put these boxes in to be helpful. You can write in the box if you want to. I think I'm going to stay with writing in this cell. We conclude that students who learned about growth mindset, we're not going to write population 1 or anything like that here. And I'm going to move down to the next line here. Have higher statistics scores than students in general. This reminds me of the old days, typing on like a manual typewriter or something. There's like 4 boxes here. I don't know why. General. And now remember, we type in the statistic. When you're typing it, you're going to put the n into a parenthesis, and the n is just 1. In fact, at this stage of the game, you can even just skip the n. Let's just write z equals, and then don't get confused and put z alpha. Just put the sample z-score. That's what your people want to know about your study. Z equals 2. And then we put, because we rejected the null hypothesis, we tell what the probability is of getting that kind of score. And the chances are less than 0.05, less than 5%. And now we are done with the problem. If we were going to write that by hand, we would just write at the end of the conclusion, Z, and you might write that 1, meaning there's 1 person in the sample, equals 2, P less than 0.05. That's how it would look written by hand. All right, I hope that was helpful.